Assalamualaikum and selamat sejahtera. Our group 1 will present about Chef Tapau for our project in the course BITS2333 for Network Analysis and Design. Our team member consists of 7 people, including myself, which is Muhammad Azimi Aqil. Our team have one Muhammad Adam, Ahmad Naqiuddin, one Abdul Rahman, Muhammad Redzwan, Muhammad Danis Haziq, and Amir Iskandar. The content of our presentation will have 10. The first one is introduction, nature of business, problem statement, scope, objective, criteria of technology evaluation, interconnection mechanism, network management and security issue, wiring scheme and cabling, addressing and routing strategy. Our first today is introduction. In today's competitive restaurant landscape, a good and efficient IT infrastructure is necessity. This presentation details the design of a new network solution for Chef Tapau, a popular restaurant located in MITC Melaka. This project undertaken for BITS 2333 aims to significantly improve Chef Tapau's communication and operational efficiency through a carefully planned network design. We will delve into a design process outlining the specific needed identified for Chef Tapau restaurant and the network component chosen to address them. Finally, we will showcase the tangible benefit this new infrastructure will bring to the restaurant's daily operation. The nature of the business for our Chef Tapau restaurant is Chef Tapau's restaurant operates as a self-service restaurant with the concept of buffet, offering an extensive array of cuisines for multi-cultures. Every customer who buy will be included in the WhatsApp groups for the purpose of sharing the daily menu of the restaurants. The customer can walk into the restaurants at Muzaffar Point, Lodge 5509, Jalan Wisma Persekutuan Melaka International Trade Center, 75450, Ayer Melaka. For catering and meal preparation for outdoor events, the customer can reach the restaurant via phone number, which is 013-640-3863, and by the email of the restaurantcheftapau@gmail.com.
Okay, so now I am going to explain about the problem statement in our project. The first one is customer experience. Customers expect free Wi-Fi in restaurants. Not offering it can lead to dissatisfaction, especially for those who work or socialize online while dining. The second one is contactless payments. Network infrastructure is essential for processing digital and contactless payments, increasingly popular due to COVID-19. The third problem statement is marketing opportunities. Wi-Fi allows for digital marketing. Customers can sign in with their email, enabling targeted email marketing campaigns. Other than that, online orders and deliveries. Managing online orders and coordinating with delivery platforms is difficult with our network, missing out on significant revenue. And lastly is business operations. Modern restaurants rely on online systems for order management, inventory tracking, and point of sale transactions. Without network infrastructure, these processes are manual, time-consuming, and error-prone. For the next part, I'm going to explain about the scope of our project. The first one is location. We will extend network coverage to dining rooms, prayer room, office, and kitchen. Next, we will install routers, switches, and cables for better performance. And lastly, we will place access points in high traffic areas for improved connectivity. For staff, we will provide internet access for processing orders, accepting digital payments, and digital marketing. And lastly, for customer, we will ensure stable internet connectivity with multiple access points and network hardware for higher bandwidth and wider coverage. Next, I'm going to explain the objectives for our project. The first one is enable Wi-Fi for customers and workers. We will upgrade infrastructure with LAN and WLAN solutions replacing outdated systems. We will install a Wi-Fi network for easy internet and internet access. Next, we enhance experience. We want to improve dining experience with strategically placed wireless access points for good coverage. It will ensure high-speed broadband for order processing, inventory management, and customer Wi-Fi. Next, remote CCTV access. We will implement Wi-Fi enabled CCTV cameras accessible remotely via a smartphone app or web interface. It is for security reasons. And last but not least, scalability for growth. We will create a scalable network architecture to accommodate future expansion and increase demand without major changes.
Assalamualaikum. So my name is Muhammad Danis Haziq bin Muhammad Ghazali. So today I will present about criteria of technology evolution. So first we go to objective. So the objective is to ensure our network infrastructure can handle the expected load in year zero by performing capacity planning for both LAN, local area network, and WAN, wide area network composite flow. So for method, we use capacity planning to calculate the maximum capacity required for each flow. This involves determining the service data rate (SDR) and using a capacity factor to find the maximum capacity need. We go to next slide. LAN composite flow. So we have identified 7 composite flow within our LAN, each with specific SDR, service data rate. The calculation for the maximum capacity needs involve dividing the SDR by a capacity factor of 0.6, as shown in the table below. We have a total 7 composite flow in our LAN. So we can see we have CF1 until CF7, and each flow has a specific service data rate (SDR). So at here we can see for CF1 the SDR is 60 Mbps, CF2 is 25 Mbps, CF3 is 20 Mbps, CF4 is 20 Mbps, CF5 is 5 Mbps, CF6 is 60 Mbps, and the last CF7 is 15 Mbps. To determine the maximum capacity need, we have to divide the SDR by a capacity factor of 0.6. So this factor ensure we have sufficient capacity to handle peak loads, accounting for potential variance and ensuring reliability. So next, for the one backbone flow, we have BB1. So our backbone flow in the one has an SDR of 85 Mbps. So using the same capacity factor is 0.6, we find that the maximum capacity needs is 141.67 Mbps. So the higher capacity ensure robust performance across the wider network, accommodating all traffic and preventing bottlenecks. So the conclusion we get is by the calculating the maximum capacities need for each flow, we ensure our network infrastructure is prepared for the expected load in year zero. This approach helps us to make informed decision about technology, investment, and configuration to support our network demands effectively.
So next, I will be presenting about the interconnection mechanism. So in this slide, we will cover the degree of hierarchy, degree of redundancy, and the improvement made by adding routers and switches. So for the degree of hierarchy, we refer to the level of connection between different areas of our network. For Chef Tapao, we have three main areas with varying level of hierarchy. As you can see in the diagram, the cloud is directly connected to the server in a one to the ratio of one, indicating the direct connection without intermediaries. And the server then connect to the server and kitchen with 2 to the ratio of 1, and finally it connects to the dining room, cashier and dining hall, surau and self-service area with the 5 to the ratio of 1. Next is the degree of redundancy. Redundancy in a network ensure that we have a backup available in a case of failure. Our design include varying degree of redundancy, and in area 1, we have a 1 to the ratio of 1 concentration, meaning there are no alternate path available and thus no redundancy. In area 2, we have a 2 to the ratio of 1 concentration, and there's a low hierarchy and one alternate unequal path. In area 3, with the higher concentration, there is 5 to the ratio of 1. We have a medium hierarchy with 1 and 2 alternate paths for providing a better redundancy. Okay, move on to the next slide. The next slide states that added routers and switches to the design. So in order to enhance our network, we have added routers and switches. A router help to manage traffic between the different areas and ensure that we stay connected to the cloud. Switcher improve internal connection within each area by enhancing performance and reliability. They set up not only improve efficiency but also provide a better scalability and fault tolerance. Uh, so, uh, Benefit of the improved design. Uh, with the improved design, the offers several benefits with a clear hierarchy, data flow and management are more efficient. Uh, and added redundancy ensures that the network remain operational even during failures. And finally, the by adding the routers and switches, it boosts the performance and allow for future scalability. Okay, next slide.
Hi, my name is Amir Iskandar bin MASSERAN, and today I will be explaining about the network management and security issue. To further increase the security, we set up the MZ switch. The MZ is a physical or a logical subnetwork that separates an internal local area network from untrusted external network, typically the internet. The purpose of the MZ switch is to add an additional layer of security to an organization local area network. An external network node can access only what is exposed in the DMZ, while the rest of the organization's network is firewall. As you can see in the topology here, we set up the DMZ switch to the router that is located between the internal and external firewall. The function of the DMZ switch in terms of traffic segmentation, the DMZ switch separates the external facing services from the internal network, limiting the exposure of the internet system. In the term of the control access, only allow the specific traffic to and from the DMZ, ensuring that any compromised public-facing servers do not provide a direct path to the internal network. In the term of network isolation, devices in the DMZ are isolated from the internal network, reducing the risk of lateral movement by attackers. In the term of activity monitoring, all traffic to and from the DMZ should be logged and monitored to detect suspicious activities. Next, I will talk about how we make sure that security around Chef Kapau is secured from any possible harm. The first step will be increasing the security network around the network equipment. We put the network equipment in the lockable location. This location will only have access only to knowledgeable employees only. Next, we make sure that it is regularly maintained for at least once a month. Next, we will create virtual local area network. We will make a departmental segregation that is separated based on departments and security level. We also implement control access lists that can reduce attack surface, such as minimize unauthorized access and potential attack vector. We also prepare for the loss of data by preparing backup if something were to happen. We do an automated backup by scheduling an automated backup of critical data. The storage of the backup must be securely offsite. Lastly, we will establish a firewall which is internal and external firewall. It will prevent unauthorized or dangerous connection. We also permit necessary and unauthorized traffic.
Okay, next is the wiring scheme and cabling that is used to implement this project. As we all know that the wiring scheme of this cable plan is using a centralized. So here are the cable, the green cable indicates the outside cable that connect to the server room. The orange cable is the cable that is connect from the server room to the store and kitchen, and the red color cable is the cable that is connect from the server room to the cashier. The next diagram is the overall overview of the cable that is connect from the server room to the others equipment in the restaurant. So as we all know that we are using a centralized wiring scheme. So all the network equipment that we put in the server room will distribute all the or connect all the devices in the restaurant from the server room.
So next is routing strategy. There are two routing techniques that we use to manipulate routing flow, which is peering and route filtering. So as we can see in both peering and route filtering diagram, there is a label of hard boundary and soft boundary. So hard boundary work as main boundary, where exterior gateway protocol (EGP) are used to pass routing information. Meanwhile, soft boundary is a main boundary where interior gateway protocol IGP is used. So for the first diagram, which is peering technique, peering is the exchange of routing information between autonomous system. So hard boundary is located between isolation and ISP. Meanwhile, soft boundary is located between all workgroup and isolation. So peering technique is implemented on both hard boundary and soft boundary. So for the second diagram is route filtering technique. Route filtering is used to hide network from the rest of the autonomous system. Route filtering also can add or modify routes to the routing table. So hard boundary is located between isolation and ISP, and soft boundary is located between all workgroup and isolation. So route filtering technique is implemented on both hard and soft boundary. Next is IP addressing. For the IP addressing, we use variable length subnet mask (VLSM). The reason we use VLSM is because we want to precise the allocation of IP address based on actual need. So by doing that, we can minimize the waste of unused IP address. So the major network address for the chef tapau is 192.168.1.0 and the subnet mask is 255.255.254.0. So as we can see in the first table, we already allocate number of hosts for each workgroup. And the second table is the VLSM table where the network address has been assigned to all workgroup. And last but not least, in table 3, there are a fixed static IP address that has been assigned to the device, which is router, switch 1, switch 2, internet server, and public server. So in conclusion, from this project, we have learned how to design a network infrastructure and propose an analysis and design to an organization, which is Chef Tapau. We also able to solve network problem faced by the organization. We also able to achieve all course learning outcome for this subject, which is network analysis and design. So that's all from us. Thank you.